Hello and welcome to C++ Weekly. I'm your host, Jason Turner. Before I get started, I would like to make you aware of my new Programming Puzzles Big Book, 400 pages of fun for ages 7 through 99. Now, the point of this book, which you may have seen me talking about on social media, is to teach all of the aspects of computer science that I personally think are important, basic knowledge for computer science. So we've got binary, hexadecimal, octal, regular expressions, assembly language, truth tables, Boolean expressions, Python, Lisp, like all the things going on here. So I think you should check this out. It is available on Amazon in a printed copy, $19.95. That's about as cheap as I could get it for a book this size. It's also available on LeanPub if you want a digital copy. I do recommend the print copy so you can actually write in it. There are links to these things in the video description, so be sure you check it out. Okay, in this episode, I want to talk about this Insidious accidental Lambda conversion. This was submitted by Ben Dean, and this is going to be one of my shorter episodes, but I really want to make the point about just how problematic implicit conversions are, and it's even the benign things that you think of as benign. I'm just going to make a quick lambda. As you can see, this lambda always returns false, so it's never going to actually succeed. Let's go ahead and run this program, and you can see that it always prints success, even though this lambda returns failure. Now, you might also observe that I'm getting a warning from my compiler here. This is GCC trunk. I'm going to go back a little bit in releases and see that we do in general get warnings from this. And the warning might be a little surprising. The address of this static blah 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 fun will never be null. Well, that's true. So it's telling me this thing is always going to succeed. Let's go ahead and choose Clang. And as we can see, it is dependent on the particular version of the compiler and what warning levels I have turned on. But I am getting the success printed. And in this case, if I go back to Clang 15, I am getting no warning at all from my compiler. It would appear that it is in Clang 19 that this first starts to warn. Now, at this point, you've probably already observed what the problem is, and that is that I am checking to see if this lambda is true. Well, the closure object actually here, but a closure object itself in this particular case, since this is a captureless lambda, is in fact decaying to a pointer. So this is equivalent to if saying, if this does not equal to null pointer, then do the thing. What we really wanted to do, of course, is actually call the lambda here. And then we get the failure printed. So this is one of those things where the average person would say, oh, of course I want to be able to do that. Like this is the kind of code that we write all the time, right? It would be something like if PTR. Now, I will say I am actually personally not a fan of this particular feature. I want to actually have to say if this thing does not equal null pointer. Like I want this Boolean conversion warning here. And in fact, there's a series of compiler flags for Boolean conversions specifically. So let's go ahead and put on succeeded back. And we know that we're not going to get that pointer warning, but let's go ahead and turn on -w everything with Clang and see if we can get any kind of warning here. Lambda expressions are incompatible with 98, auto incompatible with 98, 98 requires a new line, code will never be executed, blah, blah, blah. So I'm not actually getting a warning about the pointer to Boolean conversion. That's interesting. Clang specifically has this wbool conversion warning that would seem to imply that I'm going to get a warning if I'm doing Boolean conversion related things. And I don't. Now, I've been told that programmers don't actually want warnings on this kind of thing. But I don't think that's true. I think we do want warnings on this. So I don't know. I guess maybe you should comment and let me know if you think that we should get a warning. Not, see, the warning is that it's a tautological comparison, basically. It's saying this thing is always guaranteed to be true because it's the address of a function. I think the warning that we actually want is pointer to Boolean conversion warning. I think that's what we want. Go ahead and leave a comment and tell me what you think here. But this can cause all kinds of other problems. And I'm going to just demonstrate one more that I discovered recently while teaching a class. And yes, that does become a reminder that you should probably have me out to your company to talk about all of this stuff so that we can all together learn how to write better C++. So in this case, I am printing out this function. And of course, I get 1 because I'm getting a pointer to a Boolean conversion. I'm not even getting the address of the function, which is what I would have thought that I wanted. No, if I want that, then I have to cast this thing to a void pointer, and then that'll pick the overload that we think that it should pick, at which case it would print the address of the function. But you're not allowed to cast function pointers to void pointers, it would seem. Let's see if we can force the conversion of this thing to a function pointer. Yeah. You're not allowed to do a static cast from a function pointer to a void pointer. So we have to do the dreaded reinterpret cast here, just to try to make our point that that is how we actually get the address of this thing printed. Yes, there's strict rules about function and object pointer conversions written into the C++ standard, if you didn't know that. Anyhow, thank you for watching this episode of C++ Weekly. Be sure to subscribe. I hope you enjoyed this episode, and I will catch you next week.